first presenter is Mario Colorado, presenting on microalgae as food and oxygen, need number 1 of Travelers to Mars.
Thanks for your invitation. My name is Colorado, and I represent a team of Colombia, the Mars Society, and the Service of National Learning, SENA, and, well, South America and Latin American force for planning this project, human go to the Mars. First, we want show it the video for our project. And next, I continue to presentation. So in the video, our development is focused on the use of the microalgae and cyanobacteria. The name of the presentation is Microalgae as Food and Oxygen, need number 1 of Travelers to Mars. Well, our project is fundamental in Cyanobacterium spirula. Spirula have 2 species, Arthrospira platensis and Arthrospira maxima. These characters for structure and spirula and never generate branches. Naturally, spirulina is cultivated in Asia, Africa, and America, Central America. And now it's cultured worldwide. The culture of spirulina is the science of Aztecas in Mexican and Honduras and Guatemala. They culture spirulina over the soil. They say the stones of excrement, spirulina. Spiderland itself has been around at least 3.5 billion years. The blue-green algae become the atmosphere that the Earth and oxygen rich during the Archean and Proterozoic areas. And it's the principal idea for our project, because the nutritional characteristics like protein, minerals, vitamins, carotenoids, pigment, the microalgae like spirulina have 6.5 to 7.1% protein by dry weight. This is fundamental for food for travelers to space. Minerals like potassium, calcium, zinc, magnesium, manganesium, selenium, iron, and phosphorus. Vitamins, B1, B2, B6, B12, biotin, pantenotic acid, folic acid, inositol, niacin, and vitamin E. And carotenoids like zeaxanthin, lutein, beta-carotenes, alpha-carotenes. Pigment like chlorophyll, most abundant in the naturally, like chlorella has been, phycocyanin and porphyrin. The spirulina contains very little carbohydrates, 3.9 kilocalories per gram. It's more important for people that principally travelers for the space. And they are promising as natural supplement as long as you don't overwork. The NASA has concluded 11 studies on spiruline. Spiruline is equal many fruits and other vegetables, but for tables, the spirulina is equivalent and nutrient of 1 kilogram for balanced vegetables and fruits. For the reason, it's more easy. It's spiruline, more spiral. Spiruline is rich contain natural iron and folic acid, and to highly enhance the hemoglobin levels in the blood, but this is have found to be 60 times more absorbable than normal iron capsules. Well, our project is fundamentally in culture microalgae, spirulina, and Hematococcus pluvialis and Chlorella vulgaris. We built the rover. The name the rover is Mantis. This is not name of the project, Mantis, like for Mantis religiosa, and bioreactors for culture microalgae for produce oxygen and food, like a battery of oxygen. It's the we want. The result is a rover vehicle that's 50 centimeters by 30 centimeter platform on which a pyramidal structure. Yes, and the structure cover for panels, solar panels. And the structure divided in two zones, two areas, two sectors. Each sector containing 4 bioreactors. Yes? And each bioreactor has a nutrient supply devices and set of temperature, pH, nutrient, water level, oxygen concentration, and carbonic gas sensors. Every 12 hours, the cycle of light from LED type light is LED type is reversed to each sector. There be air, night, and day cycles are simulated. While a sector is in the phase of photosynthesis, and the other sector is the breeding phase. The result is products of oxygen continuously, and the rover is near astronaut and can be to learn long the Mantis rover will serve as an oxygen battery and food provider for travelers to prolong the walks over the Mars, over the Moon. We use easy handling materials such as plastic and aluminum. That is the reference, and this is the project we developed in Mosquera near Bogotá, Colombia. Thank you. Any question?
What will be the form in which travelers to Mars will eat or consume this spirulina?
It will be a bioreactor, bioreactors. Microalgae is in the water.
It drips out. Assuming that.
When the microalgae grow over 8 million the cells per milliliter, yes, we must pass crossing to net like 20 micrometers of diameter, the pore, and the microalgae is here, and you can obtain biomass. And
apply heat to make it dry?
But,
You have to apply heat afterwards to make it dry.
right, we dry in gas dryer.
You need another color.
Those plates and the air.
So it's air dried?
Oh, iron. Biomass.
Right, but when it goes into my mouth, what form is it in? Like cracker?
Over.
Or powder?
Powder.
So you could make
Yes.
anything with it, like a flour?
Yeah.
Like a flour?
You can't.
You can add it to food, add it to food.
The food.
Yeah.
And you can use in form barras, protein bars.
Have you ever eaten it? Have you ever tasted it yourself?
Have you eaten it?
Yeah, what does it taste like?
All right. We development in Colombia, like with various empresas, the food enterprises, development bars, spirulina and blueberries, right? And cocoa, pineapple, deshydrated. Yes. Right. It's very good for. Yes.
Does it have a taste?
In your operation, you would need to provide additional nutrients for the spirulina to grow after you've
Yes.
harvested it, right? To continue the operation.
Yes. Culture medium. Yes. First. Only. That's his. Right? Yes. The principal nutrients for culture spirulina. Water in Mars, there are water. Carbonate, bicarbonate of sodium, nitrogen, and phosphorus. We need in a few portions, yes, for produce one liter of water, culture, medium culture, produce 1 gramo spirulina. Yes,
1 liter goes
with
in
like,
So you recycle the water that's coming out from the mixture, you recycle that and run that back into the,
yes, and the water. Reciclar.
But how often?
but you're going to need to bring on the trip with you the bicarbonate sodium and nitrogen.
Yes,
And the water.
when
Well, the water
you
you can recycle.
recycle.
Have to start with something.
But then how often do you have to
feed it? Do you have to keep feeding it more as you go, or is it one time and then it keeps living?
Nitrogen and phosphorus. Carbonate makes other culture cycle they need for plants.
This is post-production processing? This is
Yeah, programs every how often?
Post-production processing after the, post-culturing processing? Is that specific?
Yes. It's close culture, but when the age cycle
Eight days. So every 8 days you give it 4 grams of bicarbonate sodium.
right.
So initially you give all this, one time you give everything, and then every 8 days you just give it
All the
bicarbonate sodium, right?
Baking soda.
And
Baking soda, yes. So is that it? Nothing else?
well, there's nitrogen.
Not the
No, but I
oxidant.
mean, does he need to, yeah, that's just the beginning, right?
with the development device for put these nutrients automatically.
Okay, so then after 8 days, you only need to give it baking soda, and then you give it baking soda, and give it baking soda, and give it baking soda. Is that it? And then it'll live for how long? Forever?
Forever, because the nutrients and the close culture, the evaporation is not.
Right, if you don't eat it, if you're just using it for oxygen, it will live forever with giving it baking soda.
So, in Hematococcus fluvialis, we were produced for 3 years without nutrients.
Wow, okay.
Hematococcus life for 3 years now, and they don't need the nutrients, but they produce oxygen.
How is the oxygen collected? How is the oxygen collected? How do you get the oxygen out of it?
Yes, and we want valvule oxygen we want to use for respiration. And the other valvula gas, carbonic gas, input to photoreactor. The microalgae take the CO2 and begin the photosynthesis and produce oxygen.
CO2 from the Martian atmosphere? CO2 from the atmosphere or recycled? Carbon dioxide from the
Are recycled. They connect to
so there's respiration.
habitats or tanks
human
for
waste.
astronauts. This is idea.
Okay,
This idea.
nice.
How much oxygen does it make per liter? So when you have 1 liter of this, when you have this 1 liter of solution with all the other things, how often does it create oxygen and how much CO2 does it take in? Do you know? Do you have the numbers for oxygen in CO2?
In Colombia, in Mosquera, we will pond cultures, and we use plastic cover over the soil over the soil, the bottom.
Yeah.
And we are culture like a video you can see. And in the Mars, the astronauts we can easy build the ponds in this planet and produce continuously oxygen.
Right. I'm just trying to figure out how much of the spirulina you need and how much of this mix you need per person to survive.
As for survive, 10 grams for each day.
10 grams
10 grams.
of
Per kilogram of body weight? 10 grams of spirulina per kilogram of body weight?
per person.
For
Per
person.
person.
For
Per
person.
person for 1 day.
For person for 1 day.
Okay, cool.
But then it keeps going, right? So if you give it more sodium bicarbonate, then you keep going, right? So if you have,
Yes, that is a prototype.
that's a prototype, okay.
The idea is a custom
So the-
higher.
The nitrogen and the other gas, those are both catalysts, and you don't need to keep adding them. They just help you add it once, and that's all you have to do with that, right?
And nitrogen, I can use urine. Urine.
Urine. Oh, urine, yes, urine.
Urine.
Okay, yeah.
Urine. Like,
okay, I got you.
Right.
So you do have to add it.
Well, you are recycling your urine.